Hello, fellow audience. Today I'm going to talk about my product. It will be a wearable device for osteoporosis patient for their rehabilitation purpose. This is a copy of poster which is being presented during Spark Night a few days ago. There are several significant contributions that I have contributed to this project. Today, I'm going to discuss three main contributions for this project. First of all, I would like to talk about the changes made in the system circuitry. Instead of using the circuitry provided, I have come up with my own circuitry with the reference of the previous circuitry as changes are being made on their components values in order to improve the sensitivity of the sensor used. Besides that, one of the most significant contributions towards this project will be drawing a printed circuit board, which also known as PCB in short. In order to obtain a compact and small overall size of the product, a PCB is necessary towards this product, as if the monitoring device can be operated by using only one PCB for the entire circuit. It will be better because with the PCB, it can improve the overall size in terms of thickness as well. A simple algorithm is also implemented for the calibration purposes of the raw data obtained from force sensor resistor. In order to obtain high accuracy data, a media filter is being implemented and threshold for force translation purposes is being calculated as well. The force calculation is mainly dependent on the weight of the individual. It is because the weight of the individual will be a huge impact towards the experimental results, as the pressure they apply on foot bundle will be different when they are having different weight. The formula will be further discussed in detail in the report, but now I would like to go through the formula briefly with every audience. The formula for threshold on force translation is being calculated with the total force of the individual being divided by the summation of mean value of 5 main pressure points, assuming that the pressure contribution on the foot will be mainly those 5 points in order to get the translation threshold that should be applied onto each sensor. Nowadays, remote patient monitoring devices are becoming well known among people in the community. Biometric wireless sensors, which typically powered by battery, are widely used to detect and monitor movement of the body, and data collected can be used for post-signal processing purposes. There are several motivations behind a variety of research being done for the wearable monitoring device is due to the tremendous benefits that everyone could obtain from them. Health monitoring device can be used for injuries prevention, early detection of disease, as well as risk management for everybody on their daily life. These motivations that I have mentioned above will lead us to the aim of our project. The aim of the project is to produce a small and compact wearable monitoring device for osteoporosis patients for their rehabilitation purpose. With the small overall size, it will increase the mobility of the device. The overall size will be one of the main attractions of the product, as it is small but it serves the same purpose with other products that have a larger size for them. The following slide will be showing a picture of a wearable device. As we can see, all components are being kept in a small black box, and 5 sensors are being shown to detect how much pressure used for each participant on the foot plantar. Now, we will look into what's inside the box. The box will consist of one piece of PCB, which include the basic circuit for the device operation and Arduino Simply programming kit. The reason behind why Arduino Simply kit is inside the box is due to the availability of the product in each stores. It is not available even though this product is being purchased at the first month of the semester. Every audience might question why did I purchase this chip so late, as it can be done at the initial state of the year. I would like to apologize to every audience, as before that, the first microprocessor that I have picked up is the smaller version of PSOP5 with Evolve another piece of PCB, but I'm unable to accomplish that PCB. Due to time constraint, I will have to come up with a backup plan and continue my project. Now, I would like to continue my presentation with the features of each component. The main component I would like to introduce, it will be the force sensor resistor. The model of the force sensor resistor that I have picked up is A401 TechScan. It does have some key features that attracted my attention, which they are very cheap, thin, flexible, and easy to use. Meanwhile, the reason behind Arduino Simply programming kit is being picked up as my backup plan for microprocessor, it is mainly due to the convenient programming environment. As a student, we can obtain Arduino software for free from its main website. The programming style of Arduino is relatively easy to pick up for a first-time learner like me. The programming kit of Arduino itself does not come with a USB port. Hence, a backup board is needed for us to load the program into the chip. The backup board is being shown on the slide. Besides that, it has almost the same features with PS5. The most important feature for Arduino simply is that it has a low power consumption, which is what ideally we want it to be. In this project, the force sensor resistor TechScan A401 are being attached to 5 different positions of the foot plantar. There's a diagram being shown on the right hand side of the slide which position of each FSR must be attached to. Those positions that are being selected for the sensors attachment are based on some literature review done at the initial state of the project. As those positions are the main contribution of pressure during body movement, sensor 1 will be attached on the heel, sensor 2 to 4 will be attached on the 1st, 2nd and 5th metatarsal muscle, and sensor 5 will be attached on the hallux, which can be known as our toe as well. Now, I would like to go through the operation guide of my device with every audience. First of all, the person who in charge of the device would like to attach 5 sensors with tape on the participant's foot as per required, which is shown in the presentation before. After that, they could start to power up the device and load Arduino code into the programming kit and run MATLAB code before they could start an exercise for data collection purposes. Here comes the experimental results of the device. There are 4 sets of exercise being done by each participants during the experiment. Experiments such as standing, walking, walk downstairs and walk upstairs are being conducted throughout the experimental period. In this case, standing and walking are being considered as basic exercise, and walk downstairs and upstairs is considered as intermediate exercise. In this experiment, the correct posture control and environmental control are being done during data collection for each participant in order to reduce the impact of posture and environment towards the accuracy of the data collected. Now, we will have a look on the raw data obtained from data collection. The first graph will be showing the raw data obtained from one of the participants for basic exercise, and the second graph will be showing raw data obtained from one of the participants for intermediate exercise. With the best position of sensors, actually we can distinguish that what kind of exercise are being done by the participants during the experiment period for basic movement such as standing and walking around. It doesn't apply to walking up and down stairs, as it is harder to see the changes in pressure of foot plantar. Walking up and down stairs are considered as intermediate exercise for this project, and it is quite challenging to obtain the correct data from each participant as they are having different walking style while they are going up and down stairs. Hence, simple analysis are required for basic exercise. Meanwhile, a deeper analysis are required to obtain better results for intermediate exercise. Here comes the fun part of the project, which is the post-signal processing part. There are several assumptions being made for the process. I have assumed that all participants are running the experiment with the correct posture and similar pressure distribution on the foot for everyone. With the post-signal processing algorithm, the raw data is going to be filtered and translate into force for a better understanding with the equation that I have mentioned above. In this case, the filter that we are using is a median filter with order 5. As we are taking changes in values, order 5 will provide us a better filter so that we could obtain a better accuracy result. Now, let's take a look on the calibrate data from one of the participants that is being shown in this presentation. The first graph will be showing the calibrate data from one of the participants for basic exercise, and the next slide will be showing intermediate exercise data collection and being calibrated by MATLAB. In order to keep the accuracy of the results, both data collection are being collected by the same individual. When both of the graphs are being calibrated, it is much more obvious and easily read by us when comparing to raw data, which is shown in the presentation slide before. This experiment is being conducted with 3 males and 2 females with the most up-to-date version of the device. Every participant is required to attach force sensors onto the required position on their foot plantar, that being mentioned before during the presentation. Each of them undergo the same experimental process, which involves of both basic exercise and intermediate exercise. From the overall experimental results from the device, we can easily distinguish that the accuracy of the device for basic exercise is definitely higher than the accuracy for intermediate exercise. There are several challenges encountered when I am producing the current device for my final year project. The learning curve of Altian Designer is relatively huge for a first-time learner like me in such a short time span. In order to achieve the aim of the project, a printed circuit board is a necessary component towards the device, as it can be created in a small and compact circuit board that is ideally to be used on the device. Although there are a lot of YouTube videos to help me to get familiar with the software, a lot of practice are required before I could completely pick up the skill for this software. Besides that, I also think that the analysis process for going downstairs and upstairs for this device has to be further improved before more accurate signal can be obtained from other participants, and better calibration algorithm must be applied for higher accuracy results. And last but not least, soldering on small and compact SMD components are one of the biggest challenges to me, because for the first time on soldering SMD component, it took me 2 hours to completely solder one component onto the circuit board. With all the time that I spent for soldering process, I think it's worth it because now my soldering skills are improved. In conclusion, I would like to thank my supervisor Mehmet Yuce for his guidance and effort on leading me to success for such interesting project. Besides that, I would like to thank everyone that helped me go through the whole project. And last but not least, I would like to thank everybody who is currently watching this video. So any questions? Thank you for listening.